we come across several concepts in optics or study of light rays. Right from standard 7 to standard 10, one has to deal with concept of rectilinear propagation of light, that is light travels in straight line, then light reflects off different surfaces. Through mirror it creates regular reflection where we have some laws of reflection. Through curved mirrors there is reflection but rays behave differently. Then we use lenses so that rays can converge or diverge. We have focal length, we have image formation. We know that our eyes themselves have lenses and there is an image created on retina. Then we have vision correction. We often see rainbow in the sky. Then we know prism can bend the rays and rays can be even converted to 7 colors, component colors. That is, your light gets dispersed. So many concepts. Let us see most of these concepts experimentally using a wonderful kit which I am going to show you sequentially in a logical continuity of activities one by one. So get ready for actual activities now. This is the light source which is connected to this power supply. It's a 12 volt 3 amperes power supply. So this is the condensing lens, a thick lens which can bring our rays together, that is placed here, and we'll be placing a plastic plate here. So we can get single ray or we can get parallel 3 rays like this, or sometimes even arrow through this. Let us begin with activities now with understanding of this setup. I'm just turning it on. So one ray has started from this and it's the beginning of our activities. I am taking a single ray from this box. This is a mirror and there is a protractor printed as well. If I place this exactly making 0 degree here, the ray is hitting the mirror and bouncing back. So practically you cannot see a reflected ray because it is same. Incident and reflected rays are going same. Now I am just tilting this to 20 degrees. You can exactly see this is 20, this is 20. That means ray that is incident is making an angle of 20 degree to this midpoint and reflecting off again at the same angle. If I make it say 30 or 40, this is now 40. It is again going exactly in 40 degree angle. So with respect to this position, it is making that angle now. This one concept. Now I'll just replace this with a 3 slits. So I am putting a plate with 3 slits. So you'll find it is giving you 3 rays which are parallel. Now these 3 rays, they are hitting this mirror at a specific angle and the reflections are also happening in the same way. So I move it and you will find these rays also keep moving. In earlier activity we had used this. I am using same mirror again, but placing one more here now, one more mirror here. So you will find these rays are once again just reflecting from second mirror. And what will happen if I place one more mirror? So there will be multiple reflections happening like this. But you can notice that intensity is reduced with each reflection. So first reflection, second reflection, third reflection. So you can change the angles and make it more interesting if you wish, like this. So there are multiple reflections using multiple mirrors. Now I have taken these three parallel rays on this metal plate, but here now let us place a concave mirror. I have this concave mirror with me. I am placing this concave mirror exactly in the path, and you can easily see a wonderful phenomenon. These three rays which are hitting this surface of mirror, they are converging together at one point. So this is nothing but focal point of this mirror. So you can see this convergence, and this is a F. So I can also turn it on this side so you can see it more clearly. Now this is a concave mirror. What will happen if I place a convex mirror in place of concave? Let us take a look. So I think this is understood. Three rays coming together at one point. Now let us place a convex mirror. Same way, but now you can easily notice that the three rays are not converging, but they are diverging. They are going away from each other. So there is a divergence of rays. This is happening because it is a convex mirror. Okay, so concept of divergence due to mirrors. Now we will do activities using lenses. I am using same plate with three parallel slits, placing it into this slot, and in this metal base we can fix this lens like this. This is a quite thick convex lens. So let us see convergence using thick convex lens and thin convex lens as well. So then we'll go for even divergence and so on. You can see the rays parallel on this platform, and I'm placing this thick convex lens here. So can you see a wonderful convergence of these rays here? This is nothing but that image formed at this point. All rays converge together at focal point. This is the rays coming from this source, that is the bulb, are concentrating here. Now you can measure this to understand the focal length. This distance one can easily measure to know focal length. I'll just remove this thick lens and place a thin lens in its place. So you will find the rays are going straight and they will come together at quite a distance. Here they are coming together. So this will be the focal length of the lens which we are using now. Once again, I'll just remove this convex lens. You can see again parallel rays, and let us place a thick concave lens here. So you will find the parallel rays are immediately diverged. I'll just remove this for once again to understand parallel rays, and the moment I place concave lens in the middle part of it, these rays are diverged. Let me show you again same activity using a concave lens which is quite thin. So I am placing this. So you will feel as if the rays are going parallel, but no, they are not going parallel now. They are diverging, but this divergence is very less. You can once again, I'll just remove this lens so you can see the parallelness of these rays. They are parallel, and the moment I place it, they diverge. So divergence and convergence using convex and concave lens, and that too with thin and thick lenses. Now a lens which is bulged in the middle is a convex lens. Can you just imagine that if you take small pieces of this lens, just imagine this, each one will be something like a prism. Prism is a non-parallel glass two surfaces which are not parallel to each other. That forms a prism. So being this is a bulged kind of surface, if you take small pieces, they will never be parallel. The two surfaces will never be parallel. So each single one will be like a prism. Now let us understand, I am using actually two prisms like this. If we place them like two prisms are placed this way, then we are forming nothing but a convex lens. And if I place the prisms in this way, we are forming a concave lens. Let us see it practically, that how will be the result of rays when they pass through two prisms placed this way, like a convex pattern. Like two prisms are placed making a convex pattern, and let us look at the rays passing through this and even opposite of it. Again three parallel rays like we earlier had with different activities. I am placing two prisms here. Now they are placed making a convex kind of pattern, and you can see easily the rays are bending and coming together at a common point. Is it not similar to convergence of a convex lens? I just now turn them around. I am just turning them around like this, and look, it's a concave pattern of two prisms, and you can see the middle ray going straight, but two rays fully diverge going away. So this is a concept of concave lens. Now let us see dispersion of light using a prism. We'll be using this equilateral prism. That means all three angles of this triangle are exactly identical. They are each one of 60 degrees. As I place this in a single ray and make some angle to this prism, it will disperse the light, and you can see rainbow colors or 7 colors of dispersed light. Let us start with the activities. Following this, we'll also try to place two prisms, and we'll try to get again same white light. There is a single ray coming out from this source of light. I am placing this prism in between and adjusting its angle so as to get 7 colors through this. So you can see beautiful rainbow formed on this white sheet. quite clearly formation of rainbow. You can see Vibgyor. I have placed one prism like in the previous activity, and this light is getting dispersed and you can see the rainbow. Now in the path of this rainbow I am placing one more prism, and you will find that it produces almost a single colored light out of it. Take a look. Now two prisms are, so first disperse the light into 7 component colors, and second prism brought them together forming again white light. So light is made up of 7 colors can be proved with this activity. In next two activities we'll be using these two types of prisms. This is a right angle prism. You can see this angle is 90 degrees. Just we'll see one activity in which the ray enters into this prism, hits this boundary, bends internally, hits this boundary of prism from inside, once again bends and becomes parallel to the incident ray. So ray was coming this side, it bends internally and comes out again from the same side parallel to the incident ray. And this is something wonderful. This round shape is something to represent water droplet in air, in atmosphere. You know, when light enters at a specific angle, it hits the backside of this water droplet, internally reflects, and while doing so this disperses and a rainbow comes out from same side from where the ray had entered. So ray enters this way, bends, rebounces, comes out forming a rainbow. And that is exactly what happens in the nature. When we see rainbow in the sky, there are so many such small droplets of water, round shaped droplets, where light enters, comes out, forming a rainbow. So while coming out, it disperses. We'll see these two activities now. Look at this single ray now. I'm just placing this right angle prism in the middle. So you can see this ray entered the prism, reflected inside, hit this surface again, reflected in 90 degrees. So 90 degree reflection, 90 degree reflection 2 times makes this light become parallel to the incident ray. So single ray, and as I place it in this, the ray bends internally and becomes parallel to the incident ray. That is the activity number 1, internal reflection using right angle prism. Now let us take a look at formation of rainbow. So I am just placing this in the path. So you will see that light comes out, it goes inside, hits the surface on the backside of this droplet of water, you could say, or round shaped prism, and it comes out from the other side and it will form a rainbow when it is hitting . So you can see a very fine rainbow created here. So refraction number 1, reflection, again refraction. So the ray bends twice, so 2 times refraction produces that rainbow on the other side. So you can see here a small and fine rainbow created. We will do one activity using this glass slab. Actually it is acrylic slab, but we typically call something as a glass slab, so I am using same term. The blue line which can be seen inside is exactly perpendicular to these faces, so you can call this as a normal. When the ray passes through this normal, it will go straight without any deviation. But when you get a tilted ray into this glass slab, then angle made to this normal by incident ray and angle made to this normal by refracted ray can be easily measured using a protractor. And you can find out sin I divided by sin R to understand refractive index of this material. So let us just take a look how it works out. You can see a single ray coming out from this source of light. If I place this slab exactly making a right angle to this incident ray, that means ray is passing making right angle to this slab, it will go straight without any deviation. But when you tilt either a source of light or glass slab, you can see the light bends, once again comes out by bending. So here also there is a bending of light, here also it is bending of light. Here it is towards normal, it is away from normal. So this medium to this medium, it is towards normal, and from this medium to air, it is away from normal. So then you can calculate this angle made to this normal. You have to extend this line further. This angle is angle of incidence, this angle is angle of refraction, to find out refractive index of this material.